Jai Hind students, welcome back to my YouTube channel. Today we will be discussing potentiometer. It's an instrument, it's a device, it's an arrangement which is used, as the term suggests, to measure the potential difference. It is actually used to compare the EMFs of any two given cells, and it can also be used to determine the internal resistance of a given cell. So before we start with this particular topic, I would request you to watch the video till the very end so as to understand the concept completely. And in between, I am going to show you a clipping so as to give you a real feel of this particular apparatus, right? So before we start, let's start with the principle of the potentiometer. So, we all are aware the potential difference or the potential drop across any length of the wire which is offering resistance R when constant current I is made to pass through it. It is given by IR. This is as per Ohm's law, right? Now, we are aware resistance offered by a wire is given by rho L by A. Rho is the specific resistance or the resistivity of the material of the wire. A is the cross-sectional area and L is the length of the wire under consideration, right? Therefore, substituting this value of R over here, what you get is V is equal to I rho L by A. Now students, if you consider the wire to be of uniform cross-sectional area, that is, if A is constant, that is, we are considering uniform cross-sectional area. We are considering uniform cross-sectional area, right? And suppose the current which is made to pass through this wire also is constant. Also, constant current is made to pass through the wire. Then, I is constant, A is constant. Rho we are aware, it's the resistivity which only depends upon the nature of material of the wire, and in a given condition it is also constant. So, all these terms are constant, therefore V would be directly proportional to L. This is, student, the principle on which the working of potentiometer is based upon. So, how to state it? How to state the principle of a potentiometer? So, the working of potentiometer is based on the principle that when a constant current is made to pass through a wire of uniform cross-section area, then the potential drop across any portion of the wire is directly proportional to the length of that portion of the wire. So this is the principle on which the working of potentiometer is based upon, right? So I hope you have understood this concept. It can be easily mathematically verified making use of Ohm's law. And students, regarding the construction part, it consists of a wooden board and a meter scale is provided, and it is also provided with 4 segments each of 100 cm of standard resistance wire. Like this. These are the 4 segments. 1, 2, 3 and 4. Each of 100 cm. And obviously, they are the standard resistance wire. They are made up of constantan, manganese or eureka. These are the alloys. They possess 2 very important properties. One is, they offer very high value of resistivity. That's why they are used as standard resistance wire. Second is, they have low temperature coefficient. What it means is that even with the change in the temperature, the variation in the resistance of the wire is almost negligible. More or less, the resistance remains constant. So these are the 2 properties which are possessed by standard resistance wire. So we make use of constantan, manganese or eureka, right? So before we proceed forward, I would like you to watch this short clipping, right? And it will give you a real-time experience or it will give you a feel of the apparatus or the arrangement which we will be making use of. And again I am telling you, please watch this video till the very end. I will be explaining some very important concepts after you watch this short clipping.
A potentiometer is used to compare EMFs of the two cells or to measure the internal resistance of a cell. The principle of potentiometer requires that the potentiometer wire should be of uniform area of cross-section and the current through the wire should remain constant. A potentiometer consists of a number of segments of wire of uniform cross-sectional area stretched over a wooden board between two thick copper strips. Each segment of wire is 100 cm long. The wire is usually of constantan or manganese. A meter rod is fixed parallel to its length. An auxiliary or driver battery connected across the two end terminals sends current through the wire, which is kept constant by using a rheostat. An ammeter and galvanometer is also used in the circuit along with the jockey.
Okay, now students, we are in a position to understand the usage of potentiometer. As I briefed you, potentiometer may be used to compare the EMFs of the two given cells, or it can be used to determine the internal resistance of a given cell. So let's deal with this particular topic. Comparison of the EMFs of the two cells, right? So let's discuss the circuit diagram for this. This is a potentiometer, right? These are the two endpoints. These are the two endpoints. This is suppose the source. This is a higher potential, these are lower potential. The source is known as auxiliary battery. It is known as an auxiliary battery. Let us represent it by capital letter E. This is an auxiliary battery, right? Its positive terminal is to be connected to this particular end. And a key may be connected over here. Then an ammeter is to be connected in series. Ammeter will tell us whether the current flowing through the circuit is constant or not, right? And in order to regulate the current or in order to maintain a constant current in the circuit, we have to adjust the resistance, isn't it? For that we make use of a rheostat. This is a rheostat. This is a rheostat. And this is connected to the other end of the potentiometer, like this. So again I repeat, these are the two ends of the potentiometer, right? The positive terminal of the auxiliary battery is connected to this end, while the other end of the battery is connected to one-way key, ammeter and rheostat. Ammeter is a device which is used to measure the current. Rheostat is a device which is used to regulate the current. Now the potentiometer is based on the principle that when constant current is made to pass through a wire of uniform cross-section area, then potential difference is directly proportional to the length of that portion of the wire. So throughout the experiment, while during an observation, we need to keep the current in the circuit constant. So for that, rheostat and ammeter is to be used, right? This is the one-way key. Now, the two cells whose EMFs are to be compared, they are to be connected in this order. This is the first cell, suppose having EMF E1, and this is suppose the second cell having EMF E2. So our objective is to compare their EMFs. This is our objective, to find E1 by E2. So these are to be connected like this. Now here, one thing I would like to mention is that the source and the two cells whose EMFs are to be compared, the positive terminal of all these three are to be connected to this particular end of the potentiometer. Will you remember that, students? The positive terminal of the auxiliary battery, the positive terminal of the two cells whose EMFs are to be compared, all are connected to the common end of the potentiometer, right? Then the other two ends of the two cells are connected to a two-way key. This is a two-way key. It is a two-way key. Suppose this is 1, this is 2 and this is See, it's a two-way, and this is connected to a galvanometer. Galvanometer, as you are aware, it's a very sensitive device which is used to detect the current. In case it does not show any deflection, it means that current is not flowing through that particular branch, right? And the other end of the galvanometer is connected to a jockey, which can be slided over these four segments of the standard resistance wire. So students, this is the circuit diagram for the comparison of EMFs of these two cells, right? Now on closing this key, suppose this is key K. Now on closing this key, how to check whether the connections are correct or not? For that, what you need to do is that you need to place this jockey at the extreme ends. These are the extreme ends. This is point A and this is point B. A and B are the extreme ends of the potentiometer. So, how to check whether the connections we have done is correct or not, whether the circuit is correct or not, whether there is any loose connections or not, how to check it? So, how to go about it? So, what you need to do is that the first step is to place the jockey at the two extreme ends of the potentiometer and check whether the galvanometer shows deflection in the opposite directions or not. If the galvanometer shows deflection in the opposite direction on placing the jockey at the two extreme ends of the potentiometer, then the circuit diagram is perfect. Then there is nothing wrong in the circuit, right? If the galvanometer shows deflection in the same direction on placing the jockey at the two extreme ends, then there is something wrong. You need to detect it. Either the connections are loose or the circuit is not appropriate. Right, students? Thereafter, what to do is, first step is, suppose connect 1 and 3. Step 1. Connect 1 and 3. So what happens is, cell of EMF E1 will come into this circuit, while cell of EMF E2 will be out of circuit. It won't play any role. So only this cell will come into the circuit. Then what you need to do is that you need to slide the jockey and ensure that the current flowing through the circuit during the procedure must be constant, right? So if you slide the jockey, then what will happen is at a particular point, which is the balancing point, the galvanometer will show zero deflection. So suppose this is where the galvanometer shows zero deflection. So you can measure the length with the help of this meter scale. How to measure it? This is 100, this is 200, and this is, it may be considered to be 20. So it will be 100, 200 plus 20. So it can be written as 220 centimeter. Let it be L1. Let it be L1. Suppose the balancing length is L1. In this case, the balancing length is L1. Right, students? And in this case, only EMF E1 is introduced in the circuit. E2 do not have any role to play. Right? Let us consider X to be the resistance per unit length of the standard resistance wire. So this is what we are considering. X is the resistance per unit length of the standard resistance wire, right? When a constant current is made to pass through it. Then this EMF is introduced in the circuit. E1 would be equal to XL1. X is the resistance per unit length. So the resistance offered by the portion L1 of the wire would be X into L1 multiplied by current. There is nothing but Ohm's law, E equals to IR, isn't it? So E1 is equal to XL1I. Put this as equation number 1. Clear, students? So at this point, the point over here and here, they are at the constant potential. So that is the reason why the galvanometer shows zero deflection. That is, no current flows through it. So no current is being drawn from this particular cell. Clear? So the EMF of this cell is balancing the potential drop across the length of the wire due to this auxiliary battery. Right? So L1 is the balancing length and X is considered to be the resistance offered per unit length of this standard resistance wire. So if the length of this portion is considered to be L1, then the resistance offered by this portion of the potentiometer would be XL1. So this is XL1 as the resistance offered by portion L1 of the wire. I is the constant current which is made to pass through it. I into R, that's potential difference. Clear, students? So this is step number 1. Now step 2. Now what to do is 1 and 3 are disconnected and 2 and 3 are connected like this. Now connect 2 and 3. It's a two-way key. So when we connect 2 and 3, then cell of EMF E2 will be included in this circuit. Cell of EMF E1 will have no role to play, isn't it? So in this case, the balancing point will get altered. Again, you will slightly jockey over the standard resistance wire. Suppose in this case, here the balancing point is obtained. Here the balancing point is obtained. Earlier it was here and now it is here. So you can easily find out the balancing length. And students, balancing point means the galvanometer at this point will show zero deflection, isn't it? So balancing length can be easily measured. In this case, if it is over here, then the length would be approximately 100, 200, 300 and over here 360. Let us assume it. So let it be L2, right? So in this case, E2 would be equal to X into L2 multiplied by I. Please ensure that during both the observations, when you connect 1, 3 and then 2, 3, in both the cases, the current flowing through the potentiometer should be constant. That is, the current shown by the ammeter should have constant reading. And that can be done by using rheostat. Clear, students? So here, L2 is the balancing length. So the net resistance offered in this case would be X into L2. X is the resistance per unit length offered by the resistance wire. I is the constant current flowing. So now what to do is, experimentally we are aware of L1 and L2. Experimentally, its value can be easily found. Now dividing these two, what do you get? E1 by E2, it would be equal to L1 by L2. So it's very, very simple. So knowing the value of L1 and L2, which can be experimentally determined as we have discussed, the ratio of the EMFs of the two given cells can be easily obtained. Clear, students? So this is the first utility of potentiometer. Here I must mention, first point is, the EMF of the auxiliary battery should be greater than the EMFs of these two cells. Then only balancing point will be obtained. So please take care. E should be greater than E1. Also E should be greater than E2. Then only balancing point will be obtained. And second is, on placing the jockey at the two extreme ends, the galvanometer must show deflection in the opposite directions. So while performing this experiment, please keep these 2 points in mind, right? So experimentally determining the value of L1 and L2, the EMFs of these two cells can be easily compared. So after discussing this topic, let's discuss the second usage of this particular device, which is to determine the internal resistance of a given cell. So how to proceed? So let's do it. We'll draw a separate circuit diagram for that. So our objective over here is to determine the internal resistance of a given cell. That is to be determined. Okay. Let's make use of the same diagram. There's a bit modification which I'll convince you. Okay. So our objective is to find internal resistance of a given cell. This is our objective. And students, you must remember the formula. We have done in the previous session. The expression for the internal resistance is E by V minus 1 multiplied by R. This is the working formula to be used. In the earlier section, we have proved this expression for the internal resistance of a cell. E stands for the EMF of a cell. EMF of a cell is the maximum potential difference across the terminals of a cell in an open circuit when no current is drawn from the cell, right? V is the potential difference across the terminals of a cell in a closed circuit when some current is drawn from the cell. R is the resistance which we are making use of in the circuit. So this is a working formula so as to determine the internal resistance of the cell. So let's consider upon the circuit diagram. So circuit diagram is more or less same. This is the auxiliary battery. Its positive terminal is to be connected to one end of the potentiometer point A, and the other end of the battery, which is negative terminal, is connected to key and ammeter, and it is connected to point B. Right, so it's same as was discussed in the earlier case. Now, this is the cell. Suppose its EMF is E. Let us consider this EMF of the auxiliary is E auxiliary. Right? Let us consider the cell whose internal resistance is to be measured, its EMF is E. And this is the internal resistance which is to be determined. Right? So again remember, the positive terminal of this cell as well as the positive terminal of the auxiliary battery both should be connected to the common end A. And this is the galvanometer, and the other end would be connected to the jockey. This is the jockey, suppose. And over here, a resistance box is to be introduced. Whatever resistance we are using, it will be known to us, isn't it? And consider another key over here. Suppose it is K dash. This is key K and this is suppose K dash. This is the resistance box, right? So this is the circuit diagram. So this is the circuit diagram to determine the internal resistance of this particular cell. Again, some very important points needs to be first discussed. First point, in order to get the balancing point, right? This is the first condition. E auxiliary must be greater than E. Means the EMF of the source of the auxiliary battery must be greater than the EMF of the cell whose internal resistance is to be determined. This is the first condition. Second condition is that on placing this jockey at the two extreme ends, the galvanometer must show deflection in the opposite direction. That's the second mandatory condition, or else balancing point won't be obtained. In case the jockey is placed at the two extreme ends and the galvanometer shows deflection in the same direction, then what you can do is check for all the connections whether they are tight or not, right? And even if they are tight and still the galvanometer shows deflection in the same direction, then what you do is you can introduce a resistance box over here. This is another resistance box. And you can introduce some resistance from here as well so as to get the balancing point between 0 and 400. Right? So this is also an option which you can explore or which you can opt for. Okay. Now let's concentrate on the procedure. How to proceed like. Step 1. When key K dash is open. This is key K dash. It is open. That is, no current is drawn from this cell. No current is drawn from this cell. So it is the case of an open circuit. So in the case of open circuit, EMF will come into play. In the case of closed circuit, PPD or potential difference will come into play, isn't it? So when the key K dash is open, so no current will be derived from this particular cell. So what it does is, we will slide the jockey over the standard resistance wire. And suppose this is where the balancing length is obtained. So that can be easily measured 100, 200 and 225. Let it consider it to be L1, right? So in that case, EMF of this particular cell would be equal to X into L1 multiplied by the constant current which is made to pass through it. X, as we discussed earlier, it is the resistance offered per unit length of the standard resistance wire. So if this balancing length is considered to be L1, then total resistance offered by this portion of the resistance wire will be X into L1, and total resistance offered multiplied with the current flowing, that will be maximum potential difference. And maximum potential difference in an open circuit, that is the EMF of the cell. It is balancing it. Clear, students? So I should be constant, right? So put this as equation number 1. Now step 2. Now what to do is, when key K dash is closed, now this key is closed. Now what to do is, the circuit will derive some current from this cell. So now the concept of TPD will come, terminal potential difference, isn't it? It will become a closed circuit. And suppose R is the resistance which is introduced in the circuit. It will be known to us. R is the resistance which is introduced from this resistance box, and its value is known to us. In this case, the circuit will become closed and some current will be derived from it, isn't it? So in this case, again the jockey is slided and new balancing length is found. Like it is somewhere over here. So the balancing length can be easily found 100, 200, 300 and maybe 340. So let it consider it by L2. So in this case, potential difference, in place of EMF, it will be potential difference because it is the case of closed circuit. So in this case, TPD would be equal to, again as per Ohm's law, it's IR. Current is I, same current must be flowing. And what is the net resistance offered by this portion of balancing length L2? It will be X multiplied by L2. X is the resistance offered per unit length of the standard resistance wire, right? And please do ensure that during both the cases, when key K dash is open and when key K dash is closed, please ensure that the current during both the cases must be constant. The ammeter must show the same reading, right? So in that scenario, dividing these two from 1 and 2, if you divide these two, what do you get? E by V would be equal to L1 by L2. So we are already aware of these values. L1, L2 can be experimentally determined. Now substitute these two values over here. So what you get is R is equal to L1 by L2 minus 1 multiplied by capital R. This is the working formula to determine the value of internal resistance of a given cell. And what about this R? It is that value which is introduced in the circuit when key K dash is closed in step 2. So the value of R which is introduced in the circuit is known to us. So knowing the value of capital R, experimentally determining the value of L1 and L2 and substituting the values over here, the internal resistance can be easily found. And students, you are aware, in any experiment, more than 3 or more than 2 observations are to be taken. And in the last step, you are supposed to take the arithmetic mean of all the observed values. And that average value will be close to the actual value. So that is how the result is obtained, right? So I hope you have understood the circuit diagram and the procedure to calculate the internal resistance of a cell. Now there are still few points to be discussed. First is, students, it might be asked in your Viva or during your practical examinations, or it might get asked in the theory board exams as well. Why a potentiometer is preferable as compared to voltmeter for measuring potential difference? Now look, students, potential difference is although it is a high resistance device, but when it is connected in parallel, it draws some current from the cell. So it do not get the actual value of the EMF of the cell. While on the other hand, using potentiometer, it is based on balancing method. It do not draws any current from the cell whose EMF it measures. So the measurement of EMF by using potentiometer is much preferable as compared to that of a voltmeter. Right? It is based on balancing method. And one more thing, students, you will prefer that potentiometer where the potential drop across the length is small, across any portion of the wire is small. What I mean to say is that potential drop per unit length of the wire should be small, and that potentiometer is much more preferable. And potential drop per unit length, that is known as potential gradient. So students always prefer that potentiometer having small value of potential gradient.